Welcome to the deep dive. Grab your metaphorical goggles because we are plunging into a world where robots are not just, clanking around.
Hmm.
They're seeing,
Hmm.
and not just seeing static pictures, but actually understanding our dynamic, messy world through video.
That's right. Yeah, we've pulled together quite a stack of sources, research papers, articles, um, all sorts of insights,
Right.
exploring this wild frontier where robotics meets advanced video understanding.
Okay.
Our goal today, basically cut through the jargon, figure out how machines are actually pulling this off,
Yeah.
show you some mind-bending things they're already doing, and talk about what it all means for you.
Okay, hold on a sec. Robots seeing video. Like,
Right.
what are they binge watching cat videos on YouTube now or something? How does that even work?
Well, you're actually not that far off. YouTube plays a surprisingly big role later on, believe it or not.
Really?
But to get there, our sources lay out a pretty clear path. We're going to start with how you, listening right now, could actually get involved in this field. Then we'll sort of unlock the AI magic that lets machines understand video,
Yeah, the core tech.
peek at some incredible real-world applications, and then finally zoom out a bit, look at the big picture, the potential, and, well, the major questions ahead.
Think of it like building blocks, step by step, from the foundational skills someone needs
Right.
through the cutting edge AI models like foundation models, vision language models,
Okay.
all the way to seeing this tech come alive, and everything from analyzing sports plays to helping robots learn tasks around your house. It's complex, sure, but we'll make it accessible.
Exactly. This is where science fiction starts hitting reality, and it's genuinely fascinating. So let's unpack this. Okay, let's kick this off with a really practical question. It comes right out of our sources.
Yeah.
If you're hearing about robots that can see and understand, and you're thinking, wow, that's cool, how do people even get into this field? What do the sources tell us?
Okay, the absolute key insight, I think, from these sources is that the gatekeepers, they're kind of gone. Yeah, robotics used to feel like this impenetrable ivory tower, advanced degrees, specialized labs.
Right, very exclusive.
Exactly. But today, it is genuinely more accessible than ever. It's democratizing rapidly.
So wait, I don't need to pack my bags for MIT tomorrow just to, like, dip my toes in.
Well, while MIT certainly has some amazing programs, no, you don't. Our sources show there are multiple on-ramps.
Mm-hmm.
The traditional route is still definitely there, University courses. Stanford's CS223A, for example, that's a classic intro to robotics, covers the fundamentals.
Kinematics, dynamics.
Yeah, all that. Okay,
Yeah.
yes, it needs a bit of matrix algebra, fair enough. But guess what? The lectures are often available online, sometimes totally free.
And MIT itself offers diverse paths. There's the XPRO program that's more tailored for professionals who need to skill up quickly.
Okay.
Then there's the foundational OpenCourseWare Introduction to Robotics course 2.12. Legendary for its hands-on labs, though you'd have to figure out how to recreate those yourself now.
Right, right. And honestly, Russ Tedrake's stuff from MIT, his freely available lectures and notes on underactuated robotics and robotic manipulation, they are absolute gold mines
Oh, definitely.
for getting deep into the advanced stuff like perception, planning, using simulation tools like Drake. It's like getting a front row seat to cutting edge research, but,
Uh,
from your living room.
and if you're maybe not quite ready for that level of academic rigor, the explosion of accessible online courses, MOOCs, is a total game changer.
Yeah.
Udacity's AI for Robotics by Sebastian Thrun famously requires no experience.
Wow, okay. That's pretty welcoming.
It is. And Coursera has fantastic specializations like Northwestern's Modern Robotics, plus courses specifically about getting started, like one from Leeds University.
Uh-huh.
ADX has options too. Some are more math-heavy, like PenX's Robotics,
Yeah.
Kinematics. Others are introductory, even touching on robotic process automation, which is kind of a related area.
So just an incredible range of stuff out there.
Absolutely. The breadth is just amazing now.
And for many people, maybe especially visual learners, the sources point to engaging video lectures and YouTube channels as the first step.
Oh, yeah. YouTube is huge here. You can find full university courses, like you mentioned, Stanford's CS223A with Usama Khatib.
Right, popular one.
Lots of MIT OCW videos, Russ Tedrake's channels again. They're all out there.
And it's not just formal lectures, right? There are channels like Boston Dynamics just showing off these incredible robot capabilities. mind-blowing stuff.
Totally.
Or PRO robots looking at future concepts, industrial giants like UK showing factory automation. But then there are channels specifically breaking it down for beginners, like the robotics channel connecting the math and code to actual physical behavior.
Yeah, making it concrete.
Exactly. Or Learn Robotics with Liz doing project-based learning with Arduino and Python. So many ways to just start building and experimenting.
So the clear insight from the sources is really this. Whether you prefer formal structure, online flexibility, or just jumping in with video tutorials, the learning resources are definitely out there. The barrier to entry.
Yeah.
Well, it still requires dedication. You have to grasp the core concepts,
Yeah.
but it's much lower.
Which are, what's the absolute must-know list, according to the sources? What fundamentals do you need?
Good question.
Yeah.
No matter which path you take, you'll definitely need a handle on some mathematics.
Okay.
Linear algebra is crucial. Describing where robots are, how they move, using matrices, vectors, that kind of stuff.
Right.
And calculus comes in for understanding dynamics and control, basically, how forces affect motion and how you make robots perform reliably.
Got it. Math and then programming.
Yep. On the programming side, Python is hugely popular. It's readable, have vast libraries for robotics. But C++ is often essential too, especially for performance-critical code where every millisecond counts.
Right. Speed matters. Okay. Math, coding, and then the core robotics ideas themselves.
Right. You'll definitely encounter kinematics. That's about motion. Purely geometrically, like how a robot's joints move its hand, ignoring forces.
Okay, just the movement.
Just the movement. Then dynamics is the flip side. It brings forces and mass into play to understand why it moves that way. Control systems is basically how you make the robot actually follow a desired path or perform a task accurately and reliably.
Makes sense.
Perception is how it senses its environment, using things like cameras, LiDAR, other sensors.
Seeing the world.
Exactly. And motion planning is about figuring out a collision-free path for the robot to get from point A to point B, navigating the clutter.
Okay. So the big takeaway for you, listening, is that the door is open. If you're curious, the resources are there. You can learn these fundamentals and get started. From free online videos to more structured courses, it's really not a closed club anymore.
Not at all.
Okay, that totally makes sense. So once you've learned the basics and maybe built, I don't know, a little robot arm or something, how do you teach it to actually see and understand the world, not just follow pre-programmed moves? Like, how does it watch a video and know what's happening?
That's the million-dollar question, isn't it?
Yeah.
And it brings us right to the heart of this deep dive, how robots are moving beyond simple sensors to actually interpreting the dynamic visual world through video.
Right.
It's a massive leap from just reacting to bumps or analyzing a single static photo.
Because the real world is constantly changing, right? Things move, actions unfold over time. Robots need to grasp that temporal flow.
Yeah.
But video data is incredibly dense. It's complex. This is where the latest wave of sophisticated AI models comes in.
Sophisticated models. So like bigger, smarter computer brains, is that the idea?
Precisely. Basically, yes. And the foundational piece of this are what the sources call foundation models.
Okay, foundation models. What are those?
Think of them like incredibly large, pre-trained generalists, often built with architectures similar to those powering the big text AIs you hear about.
Like GPT?
Yeah, similar ideas. They're trained on massive, diverse data sets. The core idea is they learn a wide range of general capabilities, understanding patterns, relationships in the data, which you can then adapt or fine-tune for specific, narrower tasks with much less new data than starting from scratch.
Okay, so they have broad understanding, then you specialize them. How does that connect to giving robots eyes?
Well, this is where vision language models, or VLMs, come in. These are absolutely key.
VLMs.
These models are the bridge builders. They learn to connect visual information, what's in an image or a video clip, with language. Text descriptions.
So they see and understand words about what they see.
Exactly.
Yeah.
They essentially learn to describe what they see and also understand language in the context of what they are seeing. Usually they pair a component that processes vision, like a vision transformer or VIT, with a language model component. And they're trained to align these two worlds, like matching text descriptions to the right images or video clips.
And the insight here for robotics is huge, right?
Oh, massive. VLMs allow robots to move beyond just following rigid code.
Yeah.
They can understand natural language instructions, like you could say, go fetch the blue cup on the table.
Oh,
And they can describe their surroundings back to a human. It just dramatically improves human-robot interaction and makes them so much more flexible.
okay, that makes sense.
And then you have the next evolution, vision language action models, VLAs.
Action. Okay, so adding movement.
Exactly. These models extend VLMs by adding the crucial ability to generate actual robot actions based on the visual input and the language command.
Whoa.
Models like RT2, Magma, these are examples trying to directly link perception and language to physical movement.
So they see it, understand what you say about what they see,
Yeah.
and then move to actually do it.
Mhm.
That's wild.
It really is. But, simply seeing and describing still isn't quite enough for a robot trying to navigate your messy living room.
Right.
They need what researchers call physical common sense.
Okay. This is a fascinating challenge the sources highlight. Because current AI can generate video that looks incredibly realistic.
Mm-hmm.
But if you watch closely, it often violates basic physics, like objects just passing right through each other or things not falling correctly.
Exactly. The AI doesn't truly understand the underlying rules of the physical world. It's just matching patterns, mostly.
So how do you fix that?
Well, research is actively trying to embed this understanding. Some approaches hope models learn it implicitly just by seeing vast amounts of real-world video. Others are trying to explicitly integrate physics principles.
Okay.
You see projects like Videoropia, which tries to make generated videos physically plausible by distilling physics understanding. Diffie fine-tunes models to be physics-aware.
Interesting.
And they're even developing benchmarks like Physics IQ just to test how well these models actually grasp physics.
So measuring the physical intuition.
Okay.
Another critical piece, the sources say, for robots operating in a 3D space is understanding that space deeply. This is where neural fields come in.
Yes, neural fields. These are really powerful methods for learning continuous 3D representations of a scene, often from just 2D images.
Continuous. What does that mean here?
Instead of just a cloud of points, they learn functions that can describe the geometry and appearance at any point in space. Think of it as a smooth, detailed 3D model learned from pictures.
Ugh.
Okay, NeurRF's neural radiance fields are a famous example. They're great at synthesizing totally new views of a scene. And the more recent Gaussian splatting is getting a lot of attention because it's much faster.
And for robotics, this is crucial. Why?
Oh, absolutely crucial. For things like knowing precisely where the robot is, pose estimation. For building incredibly detailed 3D maps, which you need for manipulation tasks, for navigating complex spaces,
Right.
and even for simulating potential interactions before the robot acts. It gives the robot this rich, high-resolution, often differentiable 3D model of its world learned directly from its camera.
Okay, that's powerful.
And finally, one more big connection. All this progress in video understanding, it's also fundamentally changing how large language models, LLMs, work.
The text-based AIs.
How? Well, LLMs are brilliant with text, right? But they've been sort of trapped in this text-only universe. They lack grounding in the real physical world.
Yeah, no eyes.
Exactly. Video understanding gives them eyes on the world.
How does that work?
Basically, video models analyze scenes, they identify objects, track their movement, understand actions, and then translate all this dynamic visual information into a format the LLM can understand.
Like text descriptions.
Yeah, maybe detailed textual descriptions or maybe more structured data about the scene. The Multimodal Video Understanding, or MVU framework, is one example of how this translation process can happen.
And the impact of giving LLMs eyes.
Huge. LLMs can now understand and reason about long video narratives. They can build up a dynamic knowledge base based on visual input. You could almost think of it as them getting visual common sense. And it enables things like real-time conversational interaction about what's happening in a live video stream. You see examples like Google's Gemini being able to analyze YouTube videos.
Right, I saw that demo.
And specific research frameworks like Stream Chat designed for this kind of live interaction.
So the big picture insight here, it's like these technologies, foundation models, VLMs, VLAs, the physics-aware stuff, neural fields, video feeding into LLMs, they're all combining to give machines, not just cameras, but the ability to perceive, interpret, and reason about the complex, dynamic visual world around them and connect that back to language and ultimately to action.
That's it, exactly. It's a convergence.
Wow. Okay, so they can see, they understand what you're saying about what they see. They have some like basic idea of physics maybe. They know the 3D space and they can do things based on all that. Like In the real world, what kind of stuff are we actually talking about?
This is where it gets really exciting and honestly a little mind-bending. Our sources are just full of examples of this tech leaping out of the lab and into everyday applications. It's not just future speculation anymore.
Right, these aren't just cool demos in a controlled setting. They're starting to genuinely transform industries and create entirely new capabilities.
Are we talking like factory robots getting slightly smarter? Or is this stuff that could actually, affect me, like personally?
Oh, absolutely affect you. And definitely not just in factories. Let's look at transforming sports analytics, for instance.
Hmm.
It's huge now.
Yeah.
AI is analyzing game footage like crazy. It can track every player, the ball, understand specific actions, not just if a shot was taken, but analyzing the exact technique. There's a system called Vice Tech that does this for racket sports.
It gives teams just unprecedented insights into player performance, opponent tactics, even helps with injury prevention by analyzing movement patterns over time. And for fans, tools like Sports Buddy can automatically generate highlight reels or even narrative video stories about a game using AI to caption the key moments. Models like GPC-4 are being used for that. It's changing how we watch and analyze sports.
That is seriously cool.
Yeah.
Okay, but what about closer to home? You mentioned robots learning tasks. Our sources talk about AI in everyday life in ways that feel, well, pretty close. Robots learning household chores. Is that real?
Yes, it's happening. The concept of large behavior models, or LXMs, researchers at Carnegie Mellon have demonstrated robots learning complex chores just by watching human home videos.
No way. So my Roomba might be watching me vacuum to learn my technique.
Yeah.
That's hilarious and kind of amazing.
Well, maybe not your Roomba yet, but potentially. And in the kitchen, there's research like the AI chef trainer learning recipes from videos. Toyota is even using generative AI, like diffusion models, to teach robots really tricky, dexterous tasks like peeling vegetables, just by having them observe human demonstrations.
Learning cooking from watching YouTube channels.
Mm-hmm.
That future is arriving faster than I thought.
It feels like it. The dream is these general-purpose robots that can actually handle the unpredictable mess of a real home environment,
Right?
powered by this ability to see and understand like we do. Research from places like DeepMind shows robots learning tasks like opening specific drawers by combining language commands, visual tracking, and sophisticated planning.
Incredible.
And of course, a major area where this is critical is advancing autonomous vehicles.
Ah, yes. Self-driving cars.
Video understanding is essentially the eyes of a self-driving car.
Exactly. Models like CLIP are used for dynamic scene understanding, not just spotting a car, but understanding it's a car that's braking, or a pedestrian who looks like they're about to cross.
Great, predicting intent.
Yeah. It's about classifying road conditions from video, predicting behavior, especially of vulnerable road users like cyclists or pedestrians. Safety is absolutely paramount, and this deep visual understanding is foundational.
And they're constantly training these models on huge data sets like the Honda Scenes dataset to improve accuracy and handle more situations.
It's also crucial, the sources say, for understanding human driver behavior from videos to help autonomous systems interact more naturally and safely on the road.
Absolutely. And building public trust in AVs, it fundamentally relies on proving that their perception systems are robust and reliable. Seeing is believing for us too.
Okay, one more area. Think about the engine driving all this research data. Training these complex AI models needs massive amounts of high-quality, diverse, labeled data. This tech is also revolutionizing research and data collection itself. Is that right?
Yeah, it's kind of meta. Manual data collection and labeling is a huge bottleneck in AI development.
Yeah, it takes forever.
Exactly. So AI is now being used to automate parts of this process. Generative AI can help create synthetic data sets that look real. Robotic process automation, RPA, can assist in curating real data.
Mhm.
And massive data sets like NVIDIA's physical AI dataset provide enormous amounts of simulated and real-world video specifically for training robots. Tools like NVIDIA Nemo Curator help process all that data.
And didn't you mention YouTube earlier?
Yes. Robots are learning directly from in-the-wild videos online. It's called imitation learning. There's a project called VidBot that learned how to close refrigerator doors just by watching unscripted human videos on YouTube.
That's amazing.
Core technologies like object recognition and tracking, using models like SSD or inception networks, are fundamental to analyzing all this video data, whether it's for labeling or direct learning.
So it creates this kind of loop, a data flywheel, the sources call it.
Exactly. Better models help process video faster and more accurately,
Okay.
which helps create more and better training data,
Right.
which then leads to even better models. It's accelerating the pace of innovation towards more capable general-purpose robots.
So the insight here is that seeing isn't just believing for robots. It's enabling them to learn new skills just by observing, tackle complex real-world problems in sports, homes, and cars, and even help us train the next generation of robots. That feels like a really significant shift.
It absolutely is.
Okay. The sports stuff is genuinely cool, and the thought of a robot learning to tidy up just by watching me is,
Uh-huh.
well, mostly hilarious. But with all this power, this seeing and understanding,
Mhm.
what does it really mean for our jobs, our privacy, our lives? What's the big picture here?
Yeah, you're asking the absolutely critical questions now. This isn't just about cool tech demos. It's about capabilities that will inevitably shape society. And our sources definitely look at both the incredible potential and the serious challenges we have to navigate.
Regarding the evolving landscape of work, the sources are pretty clear. AI and video understanding aren't just automating simple physical tasks anymore. That's kind of the old view.
Right.
They're enabling robots and AI systems to perform more cognitive functions because they can understand and reason about their environment visually.
So this goes way beyond, say, a robot arm just screwing in the same bolt over and over.
Exactly. It could be a robot inspecting complex assemblies based on subtle visual cues, or navigating a chaotic warehouse filled with unpredictable obstacles and people.
And the impact on jobs. The World Economic Forum projects pretty significant workforce shifts, right? Including reductions in roles focused on routine data collection or highly predictable tasks. The kind of stuff this AI gets good at. That sounds, well, concerning.
It absolutely is a significant transition, and it raises real concerns.
Particular.
But the sources also consistently highlight the counterpoint. AI creates entirely new roles.
Right.
Roles in developing, managing, maintaining, and collaborating with these AI systems. And crucially, it can act as a democratizing force. Sometimes it's called super agency, where individuals or small teams gain capabilities that previously required huge resources, huge companies.
That's interesting.
So the key insight here for you listening is that adapting through upskilling and reskilling, it isn't really optional anymore. It's pretty much essential for navigating this changing landscape, learning how to work with these tools.
Right. So thinking about how to work with these systems, not just compete against them, makes sense. And the broader societal implications. Beyond jobs, the sources list quite a range of impacts.
They really do. Think about accessibility. AI assisting people with non-standard speech patterns, making communication easier, or improving AI vision systems to be more inclusive by accounting for diverse skin tones, using things like the Monk skin tone scale.
That's important.
Absolutely. In healthcare, it's analyzing surgical videos to find best practices, or enhancing diagnostic accuracy for conditions like diabetic retinopathy from eye scans.
Wow. And education.
In education, personalizing learning experiences for students based on how they interact, or providing support tools for teachers, getting kids interested in AI itself.
Uh-huh. And even bigger picture stuff. Environment.
Yeah, fighting climate and environment issues, predicting floods from satellite video imagery, optimizing traffic flow in cities to reduce emissions, tracking wildfires, even monitoring fragile ecosystems like coral reefs using underwater video analysis.
Huh.
Google's AI for social good highlights a lot of these.
Yep.
It's also just a massive driver of economic opportunity and innovation across almost every single sector. And, as mentioned, it's revolutionizing content creation, making video production and analysis far more powerful and accessible. Forbes had an article touching on that.
Wow. Okay. That's a huge footprint. It really touches so many aspects of life, from our personal health to education to the environment we live in.
The potential for positive impact is genuinely enormous. But, as you rightly pointed out, it comes with significant challenges and the road ahead. The sources are very clear-eyed about these hurdles.
Like the data problem you mentioned. Needing vast amounts of high-quality training data and getting clean, unbiased data from in-the-wild videos, like stuff on YouTube, is still incredibly difficult, right?
Absolutely. Data curation, ensuring fairness, and lack of bias.
Right.
These remain huge hurdles, though automated generation techniques are starting to help. And then there's real-time performance. These large, powerful models, they're computationally intense, getting them to run fast enough for a robot that needs to react instantly in a dynamic, real-world environment. That's a major engineering challenge.
And how reliable are they outside the controlled environment of the lab? Generalization and robustness seem key. Can they handle unexpected lighting, things being partially blocked, or just weird, unforeseen events that happen all the time in the real world?
Precisely. Getting models to generalize well and be robust to novelty is critical.
Yeah.
And tied to that is ensuring safety and reliability. This is non-negotiable, especially as robots work more closely with humans.
Yeah, you can't have them just freezing or doing something dangerous.
Exactly. They need to fail gracefully, predictably, when faced with something they haven't seen or can't handle.
And understanding why the AI made a particular decision, interpretability or explainability seems crucial too. For trust, for debugging, for accountability.
Yes, the black box problem is significant. We need to understand how these decisions are being made, especially in high-stakes applications. And then there are the substantial ethical considerations the sources consistently bring up. Potential biases baked into the training data or algorithms, the impact on jobs we discussed, serious privacy concerns arising from widespread video surveillance,
Right, cameras everywhere.
and of course, the potential for misuse of powerful visual AI technologies.
That's that's a lot to consider. It's really not just about building the tech, it's about building it responsibly from the start.
It absolutely requires careful design, robust testing, thoughtful policy development, and really important ongoing public dialogue.
Mm.
There's also the fundamental scientific challenge of bridging the gap to true human-like understanding, moving beyond just sophisticated pattern matching to real causal reasoning, genuine physical common sense.
Hmm.
Benchmarks like Physics IQ and EC Bench, which tests understanding from a robot's own viewpoint, are vital for measuring progress here.
Okay. And finally, the role of simulation. It seems huge for training and testing safety.
Definitely huge.
But making what works perfectly in a controlled digital world translates seamlessly to the messy, unpredictable real world. That sim-to-real gap is still a big active area of research, right?
Very much so.
Yeah.
Bridging that gap effectively is key to deploying robust real-world systems.
Okay. So zooming back out then, this deep dive really shows us that this fusion, this convergence of robotics with advanced video understanding, fueled by models like VLMs, integrated with LLMs, it's rapidly expanding what intelligent machines are capable of.
Yeah, fundamentally changing things.
For gaining the ability to see, interpret, and act upon the dynamic visual world around us, much, much closer to how we do. From providing clearer paths for you to learn these skills and get involved, to transforming whole industries and holding out the promise of genuinely helpful robots in our homes. The journey is well and truly in full swing.
It really is.
And, okay, with all that incredible potential and also those really big challenges, where does that leave us right now?
Yeah.
Like, what's the takeaway feeling?
That's a great question. I think it leaves us at a truly transformative moment. The potential the sources hint at, it honestly feels boundless sometimes.
Yeah.
Robots, learning new skills, just by watching videos, AI uncovering scientific insights hidden in visual data, systems you can literally have a conversation with about what's happening live on a screen.
It's amazing stuff, but
But realizing that incredible future depends entirely on how we confront those significant challenges we just talked about.
right, ensuring the safety, the reliability, and critically, the ethical deployment of these immensely powerful tools.
It's really about guiding this technology towards genuinely benefiting society, fostering the innovation while being proactive and thoughtful about managing the risks involved.
This isn't some distant, maybe future anymore. This is technology that is actively shaping the world you live in right now and the world your future self will definitely inhabit.
Absolutely. And that leaves us with a really important question for you to think about, to mull over after this.
Yeah.
As robots increasingly gain the ability to see and truly understand our world through video, how might that change your own daily interactions, your work, and the opportunities you'll encounter in the years ahead?
Definitely something to mull over. Thanks so much for joining us for this deep dive. We hope it gave you plenty to think about and maybe even inspired you to check out some of those learning resources we mentioned at the start.